Hi, my name is Josh. I'm a freshman, and my position is the engineer and driver for Team 1028Z.
Hi, I'm Akshay. I am a freshman and I am a programmer for Team 1028Z.
Hi, I'm Cami. I'm also a freshman and I'm the logbooker for Team 1028Z. This video is for the Create US Open.
So basically, our design process started very early on in the summer, around early July. So we went through 6 iterations over the season. The first 2 had lifts and could do everything. So basically, they could stack caps on the low poles, the high poles, shoot flags, and park. As we progressed on in the summer, we moved away from this and thought that shooting flags would be more efficient, and because there are a lot more points available there, so controlling the flags is definitely the most important thing for the game this year. So the last 4 iterations all were ball and flag focused robots, and the 6th is the one that you see here today. And so I'm going to talk a little bit about what the most difficult thing was for the build. And so basically what that was getting the intake to intake 2 balls at the same time. So this is very important to our programming and driving because we use the scraper and cat flipper to grab both balls off of the cat, and maximizes our efficiency and points that we can score in programming, and it gives us a faster driver skills run too. So now.
So the first thing in programming is we switched from C to C++ this year due to the Vex Coding Studio change. So what this is this is basically a huge syntax change, and we had to get used to the syntax. So what we did to learn this is we kind of searched up how C++ works and how it's different from C. So for this year, we have multiple autonomouses. Our first is it gets 3 of the flags, and then the other 3 too. And this is just an autonomous if no one else has a front autonomous. So the reason we made multiple is to adjust for multiple different teammates. Maybe a teammate can do caps in the back while we do the front. And so this allows a lot of flexibility. And the way we choose between this autonomous is what I like to call the button system. So how this works is the buttons would display on here. And the buttons will have different options like the 8-point auton, there's the back auton, and you can just select it, maximizing efficiency. Now, not only is this allowing us to choose autons by just tapping rather than having multiple programs, because if you were to have multiple programs, we wouldn't be able to have the maximum efficiency of the brain because we'd be taking up so much space. And finally, I would say that the best part of our robot is the consistent autonomous. So the reason we have such a consistent autonomous is the vision sensor, and what this does is it oscillates between the value until it's perfect and then shoots, meaning it'll never miss. And the second part of that is natural progression, which is basically when it moves forward, it starts at a slower speed, speeds up, and then slows down, and it adjusts per distance. So this is a simple algorithmic process in which it'll grab the ball by going slow, fast, slow. And this maximizes what Jack and I like to call consistency and efficiency.
So over the summer, our team was able to participate in a few outreach programs that we did with the community. The first of which was a advanced robotics camp, which we took kind of some people who could sign up for a camp, and we mentored them and really showed them the ropes to the new In the Zone game. We also did this for beginners at robotics just to kind of teach them to learn the ropes and things like that. Additionally, we went to Offutt Air Force Base and we worked there, and we kind of did a Hungry Hungry Hippo game with just passerby and kind of taught them kind of what robotics is, what we're doing, what Vex is about, that sort of thing. Additionally, we hosted a tournament here at our school, and that was a great opportunity for us to kind of just explore the game more. Now Josh is going to talk about the robot's features.
So basically, our robot features 4 different subsystems. So the first is a chassis, and so that has 4 motors out of the 8 that we are allowed to use for this game. And all 4 motors are geared 1-to-1. So this allows us to be able to climb the platform because we still have torque while also having a faster speed. The second subsystem is the intake. So the intake is geared at a 4-to-1 sprocket ratio. So basically a 24-tooth gear drives a 6-tooth gear. So this gives us a faster intake speed, so we can intake balls a lot quicker than most teams. And so the third subsystem is the catapult. So the catapult has 2 motors on it instead of 1, so it allows us to shoot balls a lot quicker, and our reset time is a lot faster than teams with a 1-ball catapult. And the catapult can shoot 2 balls at the same time. And the final subsystem is the scraper / cap flipper, so it can grab both balls off the catapult for in Auton or in driver skills. So.
Okay, so most people don't really like logbooking, but it's personally something that I really enjoy. Now, our team's taken a more modern approach, and instead of starting out with 1 logbook, when we've maxed that out in the years past, we've gone through a process of getting behind, as we'd have to order a new logbook, wait for it to ship, and so on and so forth. Therefore, we started with 3 logbooks. The first logbook is the engineering notebook, and this is dedicated almost entirely to engineering. So here we have an overview of the game, just to refresh oneself with the game. And we have engineering features, kind of new designs, everything that's going through the mind of Josh and the engineers when we put into a process. Also included in this are things called design matrices. And this is basically a way for everyone, regardless of their position on the team, to have a say in what's going on. Let's say we're designing the shooting mechanism of our 5th iteration. We would rank all of the possible outcomes that we have, and we would each rank it on a scale of 1 to 10 on what we'd say. We'd average the scores, and after the highest score, we would talk about this and see if this is really what we want to do. So this is even a chance for the programmers or the logbooker to have a say in what's going on. Additionally in this, we have drawings, and this is kind of like a way for us to just check up on what our iterations used to look like and things like this. And so we have kind of, once we switched to the 7th iteration, the biggest deal for us was the ball grabber that we added, and that concludes mainly what is featured throughout the daily entries of the engineering notebook. For the second one, this has got all of the thought processes behind Jack and Akshay's programming needs. Okay, so the first part is the website, and we decided to build a website created entirely out of CSS and HTML, and we kind of featured this, that we have a link somewhere. Additionally, we have robot code, and this is basically just kind of just everything that goes on inside the robot. And so we have, daily entries here, and the Vex Coding Studio, the PID transition to C++, anything you might see. Additionally, there is a strategy section, and this is basically what goes into like our autonomy, what goes into like the shooter, driver skills, like the pros and cons of everything. And there's an About Us section at the end, just so you can get to know us a little better. In the third logbook, we have kind of what we do for the community, including the Advanced Robotics Camp and the Offutt Air Force Base, things like that. And also we have the competition results. So this is basically a way for us to, when, where, how, and how we seeded and how we turned in, and our reflections, so we can see what we did wrong, and what we did right, and how we can improve on that. Additionally, there is the code, because we just have so much coding, and we continue this throughout the logbook.
So now I'm going to talk to you, and I'm going to show you once again the button system. So if we look right over here, as of right now, the screen is empty, but if we were to tap right here, buttons would show up, and you can see the different options, and all you have to do is the simple tap of a button to choose which autonomous you want to run.
All right, this concludes our interview. Thank you so much.